Hi there. Good morning, good afternoon, good evening, depending upon where you are. I'm Kannan, one of the co-founders at Yugabyte, and really happy to welcome you to another episode of our Friday, YugabyteDB Friday Tech Talks for engineers, by engineers. And it's my pleasure to welcome today Alan Caldera, who's been with Yugabyte for several years from very early days. Alan, would love for you to introduce yourself. Tell us what you do at Yugabyte, what you focus on, and also introduce the topic and get started. So thank you very much, Alan.
Okay, thanks, Kannan. Good evening, good afternoon, good morning, wherever you are. My name is Alan Caldera. As Kannan mentioned, I've been with Yugabyte since 2018. I'm currently a distinguished engineer in sales for Yugabyte. I mostly focus on high-value strategic POCs and do investigations into new features, as well as help build the organization here at Yugabyte. Today, what I'd like to talk about is business continuity, doing backups and restores in YugabyteDB. And so let's kind of review what the purpose of backups are. So really, backups are about business and application continuity. Traditional relational databases maintain a single copy of the data online. So your DB2s, your Oracles, Informix, Postgres, only just to have a single copy while they're online. So you do backups in order to make sure that in case you lose that instance, that you can either fail over or restore from it in the event of a disaster. Since we maintain 3 copies while we're online, the focus really shifts to this is more about the application being in operation rather than disaster situations. So if we lose a node or we lose a region or an availability zone, we are able to keep going without having to resort to restoring from backups. Backups are really only needed in our situation if there are extreme scenarios where multiple copies of a particular tablet or tablets are lost, as well as application corruption issues. So people dropping tables, people doing updates that don't make sense, things of that nature. We've all been there before. So let's talk about what YugabyteDB offers as far as backup restore. So the first important thing is that it can be run while the database is online, and it produces a topologically independent backup format, which means it doesn't matter how many nodes I'm running on or how many copies I'm running. I'm only going to save a single copy of the data, and I'm going to do it in such a way that I can move between different numbers of nodes, different environments, different replication factors without having to take another backup. When we do our backups, all the nodes are backed up and restored in parallel, and we can configure that, and we'll dive into that. We have a number of file stores that we can process, that we can send our backups to. So they are AWS S3 and compatibles like MinIO, Google Cloud Storage, Azure Blob Storage, and of course our old friend NFS, whether it be on a filer, whether it be data domain, or just a Linux server serving a file system out there. And finally, as far as the scope of backups, backups in YSQL, our Cassandra compatible API, can be done at the table or key space level. But for YSQL, Postgres, we decided to stick with Postgres's concept of maintaining database consistency for a single database. So right now, the database is the level at which backups and restores are done. I'd like to introduce kind of a core concept now in Yugabyte called snapshots. And so a snapshot is basically a stable version of all of the flush SST or sorted string files that are at a specific point in time. So that basically we have a consistent view across all of the nodes out there, how of what the data is at a specific moment in time. And so basically we do this by creating hard links to these files in another directory that lives on each tablet that contains these hard links. And basically this allows the system, while the system is still flushing new data and compactions may be going on, then these files stay basically, since they're immutable anyway, all new updates go to new files, then we're able to basically maintain a stable set that looks the same throughout the backup, however long it takes. And then at the end, we will delete the snapshot when it is done. If you don't delete the snapshot, basically what happens is as you continue to add data and data is compacted, those files now become, they may be delinked in the primary store, but since there's still a hard link, they become real files. So you can start consuming a heavy amount of storage if you don't remove these older on-disk snapshots. So let's talk about
Alan, maybe one question on the previous slide.
Yeah.
If you could speak to, typically like how quick the snapshot operation is. It essentially clarify if it's online or not. Does it like
so
the size of the data?
Yeah. So thank you, Kannan. So the snapshot. So we're online while we're taking the snapshot, and typically this is a matter of seconds because we're basically going through and traversing all of the tablet directories on each server in parallel, going and creating these hard links, which are very, very lightweight. And
I remember, like, the very first version of the snapshots that we built like 3 years back was only single shard consistent.
Right.
And then quickly we followed up with like adding, multi-shard consistency, which is like basically needed for a distributed ACID compliant database supporting features like SQL. Any insight into like, you want to share like what is the kind of main intuition? How do we get to that multi-shard consistent snapshot?
So yeah, so the great question, Kannan. So we get to that multi-shard consistent context by basically taking by doing the flushes at a consistent hybrid time across all of the
shards and tablets. Yeah. I think I just wanted to call that out. You mentioned it in your first bullet. Essentially, it's even though the operation may not happen at the same time, but the snapshot that we take is specified at a particular point in time, and we use the same point in time across all.
Yes.
Yeah. Thank you.
Okay, so let's talk about how we actually back up a database. So this is how it's configured using our Yugabyte platform. So we need to a place to put our backups. So we have a number, as I mentioned before, we have a number of different providers, as I've said before. And so on this screen, basically, we're going to give it the proper credentials and locations of where the S3 file store is, whether it's on Amazon or on another host, the bucket name, any AWS secret information that is needed. If you don't want to provide a secret, then it can actually just pull from the IAM role that's talked about here. You can configure multiple different S3 backup points, depending on what your requirements are. And I believe we are also allowing you now in the case of geo-replication, allowing you to each region to back up to its own to its own file store in that situation, so you're not having to cross regions when moving files around. So after we've actually created our provider, then we can actually go and create a backup. So I've gone to this screen here where I basically say, okay, I'm going to create a YSQL backup using the default S3 that I configured earlier. And then I'm giving it a database called Northwind, which is a really small database. I've also got the option of encrypting a backup. Now, encryption happens, when you have, we can support encryption at rest within Yugabyte, whether you use our feature or whether you're using it at the EBS or cloud volume layer. But all the cloud providers basically allow you to encrypt transmissions going, the data going to your buckets using either their managed keys or your customer supplied key. So for AWS, the other providers actually do it by default. AWS is the only one that basically gives you the option to turn whether it's selected or not. So on other providers, this particular slider does not appear. Then we can also discuss how many parallel threads that we want to run concurrently. So we're going to be going to each node and basically spreading that number of threads across each node separately. So the more nodes you have, the more threads you can run. And this really is allowing you to basically say, well, how much impact do I really want to take on my production load while I'm running? Okay. And finally, we want to basically say, well, how long do I want to retain this backup? So we give you this option so that basically, you don't just leave a backup out there and keep sending Jeff Bezos money by spending your disk dollars on things you don't need anymore. So we give you a way to basically say, okay, this is how many days we're going to retain. When we hit that retention period, then we remove the bucket at that point, the backup at that point. So while the backup is going up, what's actually going on behind the scenes? So let's talk about the steps that we actually go through. And these are documented in more detail at the link there on the screen below, at the bottom of the screen. So in the case of a YSQL backup, the first thing we're going to do is we're going to check the actual catalog version for the database. So we want to see what the state of the catalog is at that particular point in time. Then we're actually going to quote unquote create the snapshot, which is another YB admin command, RPC command that basically says, okay, go out and actually perform the snapshot that we talked about earlier. After you create the snapshot, go ahead and export using our version of PG dump, which is called YSQL dump. We're going to actually export the catalog's notion of what the tables are and the indexes and all the column names, etc. And then after we finish that, basically we want to check the catalog version again, and I'll defer that why we do that for the next slide. Finally, we're going to export the snapshot and actually copy it out to S3. And then for each table on the nodes where we have leader tablets, we're basically going to copy the snapshot directories, not the, that are just the hard links, not the actual, we're not actually opening the files and drawing the data out of the database. We're actually taking the physical file and moving it to S3. And oh, by the way, along the process, we also do a checksum to make sure that we get a good transmission back, when we do restores later on. And finally, if you have our encryption at rest turned on, we will also save the encryption key on your S3 bucket, so that when you go to restore that backup, then you have the key to actually decrypt the data at that point. Okay, so why all the fuss with rechecking the catalog version? So the simple answer for that is consistency. So the snapshot file contains what DocDB's notion of what the table schema as well as the tablet information. So in there, we've got the attribute names, what the last column position is, and what the order of the table. So the schema must match what DocDB has with what the catalog has. So because it must match the number of objects, the attributes, and the order of the objects. Okay, if there is a mismatch between the two, then your restore will fail to come back. So that's why we do that particular check. So at the end here, we've got a complete backup. And so the important thing to note is after the task is complete, it will actually update and say, okay, we ran about a minute. In this case, this is a small database. And there's a storage location click box where you can basically say, okay, if I want to go take this to another cluster, potentially even a different platform, that then I can actually say, okay, here's the S3 location where this particular backup is stored.
Alan, there was one question. What happens if a node fails during a backup, or say a leader or tablet moves during the backup?
Yeah, so in the case of that's a great question. In the case of a tablet, in the case of a leader fail, the snapshot is actually taken on all nodes. So, excuse me. The snapshot is taken on all nodes. So
Alan, maybe I'll take that answer while you catch your throat. I think is
sorry.
So essentially, like what Alan was saying was, firstly, if you remember, the building block to doing a backup is firstly taking an in-cluster snapshot. The in-cluster snapshot itself is a very lightweight operation. We take those snapshots. They are more like, think of it like logical references you are holding to the copy of data using this hard link mechanism on each node. And so we take the snapshots on all the replicas as well. So if you're replication factor 3, for every tablet, we have an in-cluster snapshot per replica. So that's why we're able to handle node failures, because then once the snapshot is taken and you're trying to copy these things to a backup for an off-cluster backup, if there's a failure, we can always try at the new leader to copy out that particular shard's worth of data.
Yep.
Thanks, Alan. Go for it.
Thanks for the break there. Okay. So, and then this is a view of what it looks like actually in S3. We have the copies of the snapshot itself that we talked about earlier, and then each tablet's SST files along with a checksum that actually is stored up there as well, that we'll use during the restore process. So how do we actually restore? So let's take the backup we just did, which was on an RF3 system, and take it to a single node cluster. And so let's say that this is basically a development database, or maybe even someone's laptop or high-end server sitting on under their desk. And we want to actually restore this. So now we're going to bring up the restore panel and say, okay, I've got this same S3 location, and then I paste the location that I copied earlier from the other platform, and then pasted this in the storage location box. And then I designate which universe it's going to and the name of the database. The name of the database can change, so you can actually restore it to different different names multiple times as you need. And then also I can select what degree of parallelism, again, that I want to actually maintain. And finally, if I have any encryption at rest enabled, then I can select which configuration I actually want to use. The table box is actually reserved for the YSQL API tables, where we can do single tables at that point. So what's going on when we actually restore? So the first thing is we're actually going to copy down the dump file that we created for the schema, and basically create a copy of the database schema on the new cluster. So at this point, it's taking all of the tables and creating new tablets that match this particular cluster's configuration, and laying them out on the servers as they're needed. So once that's complete, then we copy the snapshot down and import it. And what this does is this generates all of the different tablet UUIDs and table UUIDs that are necessary to basically give what the location where we should actually place this data. So we process that internally and say, okay, now we're going to copy each tablet snapshot data from S3 to all of the tablet peers. While we actually just only made one copy going out, we actually have to construct the appropriate number of copies coming back. So we need to copy it to all the tablet peers at this point, including read replicas. And then finally, we restore the snapshot to actually make it visible to the cluster. So this is the end of my presentation. I'd like to remind you on the 1st of April that we'll be doing a presentation on point-in-time recovery with these two APIs. So please join us then.
Alan, there are a few questions. Thanks a lot, by the way. And reminder that a continuation of this talk is happening 2 weeks from now. There's a different topic for next week, but 2 weeks from now, we'll cover the point-in-time restore. Let me go through some of the questions that have come in on the channel.
Okay.
So Alan, one of the questions is around, there are parts of the demo that you were showing the platform view, which is not part of the open source offering itself, like
right.
It's part of the enterprise. So questions were around, that what does what does open source, if a user is just using us in open source, are they still able to build all of this with some tooling? If you could answer that.
Right. So we have great point. So in the on the doc links that I showed, there are all of the commands necessary to actually using the YBadmin tool to actually go through and identify what where all the tablet leaders are, and where all the how to actually import the snapshot. I can bring that.
Yeah, maybe I can. One way I would say it is like there are a bunch of steps, like creating a snapshot, figuring out where the which folders, which nodes those things lives in, so that you take the off cluster backups. But there is a fair amount of tooling. In fact, we are aware that some folks have actually built a lot of that using the open source APIs. And maybe one of them been talking to, maybe we'll invite them as a guest speaker on one of the Friday Tech Talks. So they built some really cool stuff end to end, just using the open source. And yeah, I think that would be cool. Like, because there is some of the retry logic, like if you list the snapshot, find its locations, but by the time you're about to copy it, suppose the locations have moved, how do you handle that? How do you do the retry logic? So there is a bunch of stuff which today, that part of it, the tooling is more through the tool that you saw, like the platform that we saw, it's in the enterprise edition, but it can be built, and we'll try to invite one of those people who have built it as one of the guest speakers in a future talk. Let me go through some of the other questions. One other question is, are temp tables also backed up, and does dropping a temp table cause the catalog version to change, catalog schema version to change?
Yeah, actually it does. So the temp tables themselves are not backed up, but it does cause a catalog mutation at that point. So it's just something to be aware of in the process, to make sure that you don't actually capture that information while you're doing that.
Yeah. So one comment was simply that, hey, it is also possible to use the RPC API to the system to automate large chunks of this, rather than sort of the command line binaries like YBadmin and so on, which is very true. I think, in fact, Radek, who commented on that, he's actually built one using the RPC framework, the gRPC calls to. Let me go through a few more of the questions.
Okay.
Can we back up and restore between different versions of YugabyteDB?
Yes. So yeah, so the backup format is independent. So I think we're a long way away from having metadata changes down at that level. So
the only thing I would add is, sometimes in newer versions we do newer structures. We may change, like, a Bloom filter type of property, or say, suppose we do packed columns, right? Recently we did advanced delta encoding. So when you once you start using newer features and you take a backup from, say, 2.8 of Yugabyte and you want to restore to 2.0 of Yugabyte, that won't work. So there are some features that start to change on disk structures, but usually the reverse is fine. If you took a backup on 2.2 of Yugabyte and you want to restore to 2.8, that should be just fine.
Yeah, that's fine.
Let me look for a few more questions. There are actually quite a bunch more, so we'll try to take maybe two more of them. One comment was, it would be great to mention this change data capture need to restore the snapshot to another environment if you want to restore all day and not just the data from the snapshot. I didn't fully understand the question.
Oh, okay. So this is a log apply scenario. I think that's what the person is talking about there. So this is right now what we offer is just basically, this is a full backup. And then so in our X cluster implementation, we actually use backups to actually initialize a cross cluster replication scenario, and then you could set up the X cluster replication to keep the new data up to date. So basically, you give it a point in time by taking a bootstrap mark to say, okay, here is where I want you to start replicating from, and then after you restore your backup, then you can set those marks and initialize replication. It'll catch up from the other cluster. We don't really do log shipping type replication the way other relational databases do.
Yeah, I mean, so incremental backups is definitely a feature that we plan on working on. I think we have some early stage progress towards it, Alan.
Yeah.
And then change data capture independently is an alternate mechanism to subscribe to just changes happening in the database, but that is, I would say, more than this. This is more of a physical backup type of strategy, whereas change data capture gives you a logical way to subscribe to changes happening in the database and apply to apply something to another microservice, like a search microservice, for example, right? Maybe we'll take two more questions. There was one comment from another user saying they have written a lot of this this entire snapshot mechanism and writing to GCS. They have also automated all of this using open source. They've done it in Bash. So thanks for that input. And one other question is, can you simply restore a portion of the snapshot? That is, just restore one table?
No.
Maybe there's a clarification there, Alan, for our Cassandra compatible API, I believe.
For Cassandra, yes, but not. But even then, it's.
But Alan, that's just a current limitation because of the way we are restoring the entire the database level. But it seems like that is something that we can work towards providing a finer granularity.
Yeah, table level restore. Yep, a very popular feature.
Yeah. All right, we are a little 2 minutes over time. Want to really appreciate both the questions from the audience and the engagement. Thank you, Alan, so much for your talk today. Would like to encourage people to ask questions on the Slack community as well, and continue the discussion if there are more questions. And have a happy Friday, rest of the day and weekend. Thanks all.
Thanks.
See you next Friday.